This is 7.3, solving linear systems. Wow, that sounds familiar. By adding or subtracting. This method is actually called, it's called elimination, and that is exactly what you're going to end up doing. You're going to end up eliminating one of the variables. So you have learned, this is going to be your third method. First method you have learned to solve a system is to graph. The second method you've learned is to substitute. And this last one is going to be eliminate. Those are the three different methods. So how do you eliminate to solve a system of equations? What you do is you actually end up adding or subtracting the entire equation. You add the entire equation or subtract based on what you need to do in order to eliminate an entire variable. Remember, we can only solve for the value of the variable if there's one left. Then you'll get the value of the variable and you can plug it back in. So if you've got this system, you've got x plus 5y equals 9, x plus 5y equals 9, and 4x minus 5y equals negative 14. And I do strongly recommend you writing these up and down like this. So you've got your x's, you've got your y's. Now, do you see that if I added or subtracted these equations, I could completely eliminate or get rid of one of the variables? Well, if I added these two equations together, positive 5y and negative 5y would end up being 0, and they would disappear. Because 0y goes away, 0 times y. And all I would be left with is 5x equals, yes, you have to add these as well, negative 5. So what I did to get this is I decided to add these equations so that I could add, let me move that so it's easier to see. So what I did was I added my x's, x plus 4x. When I add my y's together, they are eliminated because that's 0y left over. And then I also added my answers. You've got to add it all. But now that I have that, I can solve for the value of x. And x equals negative 1. Now that I have my value of x, I can plug it back into any one of the equations. X plus 5y equals 9. And now I know that negative 1, plus 5y equals 9. That means that 5y's got to equal 10, so y has to equal 2. You have an x value, you have a y value, and now you have a solution for the ordered pair that solves your system. Take a second, let's check to make sure that works. Negative 1 plus 5 times 2 equals 9, you bet. Negative 1 times 4 minus 5 times 2, and that equals negative 14. Yep. So we did find the one solution that works in both ordered pairs. So let's see that again. You've got 3x minus 4y equals 2, and 3x plus 2y equals 26. Now, do you notice that I have the same coefficient for the x's? I have 3x and 3x. I can make those disappear if I subtract these equations, because 3x's minus 3x's give me 0 x's, and they're gone. But be very careful when you go to do your y's, because this is negative 4y minus 2y. That's actually negative 6y. And 2 minus 26 would give me negative 24. That means that y equals 4. This is probably one of the easiest methods to do, and kind of, I think it's the most fun, but you know I'm weird. So now that I have the value of y, I can plug it back into either of these equations. Equals 2 to find my value of x. So 3x, add 16 to both sides, and that means x is 6. So the ordered pair has an x value of 6 and a y value of 4. And let's double check to make sure that works. So 3 times x would be 18, minus 4 times 4 is 16, and yes, that equals 2. 3 times x is 18, plus 2 times 4 is 8, and that is 26. Both of those work. So let's check this out again. Look at your checkpoints. Now, you always are looking for the variable that has the same coefficient, either opposites or the exact same. And this is -8 and +8 for the x. So that means if I add these equations, my x's are going to disappear, and I have 3y plus -9y. That gives me -6y, and 12 plus 12, 24. So my y equals -4. And now I can take that y value and plug it in for any of the equations. I chose the second one. And so 8x, let's subtract 36 on both sides, equals -24. You should be solving these equations efficiently enough to not have to show every single step. You really should. You absolutely must show your elimination and your answer, and you must show your plug-in and your answer, and then you can get your big bad ordered pair. Those are the 5 things that I'm going to look for on a test. And then quick do a mental check of your original equations, and let me erase this so I can see them. So my x is -3, and -8 times -3 would be 24 minus 12, and that is 12. 8 times -3, this time it'd be -24 plus 36, and that would be +12. So that is the ordered pair that works in both equations. So let's do this for this one. Now I have the same y's, but because they're both positive, 6 and 6, to get rid of it, I actually have to subtract these equations. It's going to get rid of my y's, but 1x minus -2. This is where you're going to get killed by not knowing your negatives and how to subtract them. 13 minus -8, 21. So I did 1 minus -2 to get 3, and 13 minus -8 to get 21. And that means that x has to equal 7. Plug it back into one of the equations, and let's do the easier of the two. So 7 plus 6y equals 13, and that means that 6y has to equal 6. So y is 1. My ordered pair is 7, 1. My ordered pair is 7, 1, and let's check to make sure that makes sense. So 7 plus 6 equals 13. Yes, it does. -14 plus 6 equals -8, and that works too. Okay. Sometimes, though, they aren't going to be set up as pretty for you, but they were really, really easy when I had them set up x and y on the same side, lined up perfectly. So this is kind of what we're shooting for elimination. So if you're looking at equation 2, that's not set up for elimination. So let's rewrite this. And to do that, I'm subtracting 6x on both sides. So my first equation, 6x plus 7y equals 16. And now my second equation, it's going to be -6x plus y equals -32. So this equation I rewrote to be this one so that I could then add these and get rid of my x's. So that's 8y equals 16 plus -32 is -16. Means y is -2. Plug it back in. I would always plug it back into an original equation and not one you've messed with, but I'm going to plug it back into the top one just for safety's sake. And that means 6x, so that means I've got to add 14 to both sides. X equals 5. So now I know my ordered pair, my x is 5 and my y is -2. And let's check to make sure that this works. So 30 minus 14, that equals 16. And -2 should equal 30 minus 32, and it does. Okay, so again, we need this to have the x and the y's on the same side. So 4x minus 5y equals 5. Let's subtract x on both sides to get that all lined up. And since I have -5y and +5y, I'm going to add these. Now, do you notice that I leave this kind of gap for the 5y completely open? It kind of helps me remember that I've eliminated the y. So now I'm solving for x. Just kind of a habit thing. You can do it. You don't have to. but 4 times 5 minus 5y equals 5. And that means negative 5y equals negative 15. So my ordered pair, my solution would be 5, 3. And let's check to make sure that works. I know, a box this time. And 4 times 5 would be 20, minus 5 times 3 is 15, and that does equal 5. And 5 times 3 is 15, and that equals, my x is 5. 5 plus 10. And that works in that equation too. Nicely done. So here I'm going to write down the one that's pretty first. And then I'd have to add 2x to both sides. 7y equals 4. And now I have to subtract these to get rid of my x's. So I've got negative 6y equals negative 12. Negative 8 minus 4. So my y equals 2. So 14, but I subtract 4 on both sides. And that means x equals negative 5. Negative 5, 2. Now, remember that the homework has these answers for you. It's kind of nice because then I know I'm doing the right process. So you can go on the homework and double check that your answers are right and that your answers match. And that will be kind of helpful. One of your homework problems is very much like this, and so I wanted to kind of help you out and show you in advance how this is going to look. But a river boat travels 4 miles per hour upstream. It travels 6 miles per hour downstream. The speed of the current remains the same during the travel upstream and downstream. So we're going to find the average speed of the riverboat in still water and the speed of the current. Now, they just gave us 6 miles per hour and 4 miles per hour. Those are totals, so this is a mixture problem. They didn't tell us how much and how many, but they gave us one answer for upstream and one answer for downstream. So those are going to be my equations. So my answer for upstream, I'm wondering if you can see this. It's a little rough, I know, but my answer for upstream is 4 miles per hour, and my answer for downstream is 6 miles per hour. Well, think about what going upstream means. It means the speed of the boat is fighting the speed of the current. So however fast the boat is going, you subtract the speed of the current because you're fighting it. But if you're going downstream, the speed of the boat is being helped by the speed of the current. So these are my two equations. And now I would line them up. So let's line them up nice and pretty. So first one was upstream. My upstream is x minus y equals 4, and my downstream is x plus y equals 6. Now, it really doesn't matter which one you do, add or subtract here. I'm going to subtract these to get rid of the x. Well, careful. This is negative 1 minus 1. That's negative 2y equals negative 2. That means y equals 1. So in my equation, that means x has to equal 5. So in my story, my ordered pair is 5, 1. That means the speed of the boat is 5 miles per hour. And the speed of the current is 1 mile per hour. So when it's helping, it goes faster. When it's hurting, the speed of the boat goes slower. So there are your answers here. And here is your homework.